In this video, we'll discuss about current division rule. So it is one of the basic but important rule that you need to know. So before you talk about current division rule, the first thing that you need to know is current only gets divided among resistors when they are connected in parallel. Now, if we consider this circuit, in this circuit, R1 and R2 are kept in parallel, right? So the overall resistance for this circuit is R1 in parallel with R2. That means R1 R2 divided by R1 plus R2. This is the overall resistance for this circuit. Clear? Now already we know that current gets divided when resistors are connected in parallel. So let's say this is the source current that is flowing due to this voltage source. Now when this total amount of source current is passing through this node, then it gets divided into two parts, namely let's say I1 and I2. Now what do we want to find out is the value of I1 and the value of I2. Clear? So now what we can write is that what is the voltage drop across this resistance R1? So that is V1, that is equals to the current passing through this resistance multiplied with the value of this resistance, that is I1 into R1. Let's name this equation 1. Right? Now if we apply KVL at this loop, our equation will be what? Vs is equals to Is into R equivalent. What is the value of this R equivalent? We already know, that is R1 R2 divided by R1 plus R2. So that is our equation number 2. So now we want to find out this value of I1. So we can see from equation 1 is I1 is equals to V1 divided by R1, right? So now we can see these resistances are connected in parallel with this voltage source. So that means V1 is actually equal to Vs only. So we can write, instead of V1 we are writing Vs divided by R1. So now from equation number 2, if we just substitute this value of Vs in this equation, then we will get this value of I1. So by substituting the value of Vs from equation number 2, what we will get is this Is multiplied with R1 R2 divided by R1 plus R2 into 1 divided by R1, this R1. So R1 gets cancelled. So your equation becomes I1 equals to Is into R2 divided by R1 plus R2. So that becomes the current that is passing through this R1 resistor, right? So what we can see is that the current that is passing through this resistance R1 is equal to the source current, that is Is, multiplied with the other resistance divided by the sum of two resistances. And in voltage division rule it was what? The source voltage multiplied with that resistance divided by the sum of the two resistances, right? So now similarly what we can write for I2? So our I2 will be the source current, that is Is, into other resistance. Since we are finding out the current passing through R2, so we will write over here R1 divided by R1 plus R2. So this is the amount of current that is passing through R2 resistance. Clear? So what we can write is I2 is equals to source current into other resistance, that means R1. Why other resistance? Since we are finding out I2, so this is why we are saying other resistance, that means R1 divided by the sum of two resistances, that is R1 R2. Hope I am clear. Now let's take an example. So this is the source current. So what will be the current that is flowing through this branch? let's name this I1 and let's name this I2. So our I1 will be what? I1 will be the source current, that is 10 over here, into, since we are finding out the current that is flowing through this branch, so we will consider 10 for this, 10, that is the other resistance, divided by the sum of two resistors, so that means 12. So it becomes 8.33 amps. Clear? And what will be your I2? That is the current flowing through this 10 ohm resistor, is the source current, that is the 10 ampere, into other resistance, that is 2, divided by sum of two resistors, that means 12. So that will be your 1.66 amps. Clear? And also in this case also, if you just sum these two up, then you will get approximately 10 amps. Clear? Hope you understand. And this is the end part of this video. Thanks for watching. See you in the next video.